Welcome back, Math 9, second topic, 7.7, identifying types of symmetry on the Cartesian plane. I'd like to give a big shout out to Rami, missing right now. I know you're listening at home. Okay. On this grid, take a look at this grid because I'm reading about it. You guys better be looking about it. On this grid, rectangle A has been rotated 180 degrees about, and this is where it gets tricky, E. Now, you guys are aware from grade 8, X comma Y, right? Don't be doing that. Negative 1 comma 2. Now, I'm going to write something above that negative 1 and 2 in case some people forget. And that's fine. What I'm writing down here is that X comma Y is how these ordered pairs are always given. Correctly, anyways. You can give them incorrectly a lot of ways. Okay. What that means is the x-axis is always the horizontal. Oh, sorry. Negative 1 and 2. You see where they intersect right here? That's the spinning line is what we're saying, right? So if you started with A, I'm going to draw this again. Rough. I said, I'm going to spin that around with that dot as my spinning line. Can you use your imagination and spin that? Some people can. People who played Minecraft are better with doing things in their head like this. Not saying Minecraft is great, but I've noticed that 20 years ago, nobody knew anything. So, if I take this shape and I spin it around, you can imagine, and it works better, it doesn't show up on video here, transparency-wise. Anyways, where's my clear sheet? I had it out. So this won't show up on the video, but if I make this transparent shape, start with A, and I don't have B original. You guys see what I'm going to do? I'm going to say it's spinning around this dot. Okay. This is my center, right? When I spin this, then there it shows up. You guys follow that? Now my transparency is wobbly, but that's what we just did. And that doesn't show up on the video what I was just showing now. Good. The line through negative 1 on the x-axis is a line of symmetry for the two rectangles. Each point on the rectangle has a corresponding point on rectangle B. These points are equidistant from the line of symmetry. So I'm just taking a look at something. I've moved something. And I'll just pause the video for a second. I had to fix that up, video people. So I actually shifted the shape over. You guys can redraw it over there. It actually had to spin like that. I was making this out on her and I did the wrong thing, obviously. Okay? So you guys fix that up there. That's where it's fun. I didn't realize it until now. Okay? So if you spin that upside down for 180 degrees, that's where it's fun. Have you fixed your sheet? Okay. Split that over. These points are equidistant from the line of symmetry. Okay, when a shape and a transformation image are drawn, the resulting diagram may show no symmetry, line symmetry, rotational symmetry, both line and rotational symmetry. Going back up to this, You see that A and B have a rotational symmetry and they have a mirror line, right? We have line symmetry and mirror line symmetry. Keep drawing a blue line here. Okay. Back to this example. For each pair of rectangles, determine whether they're related by symmetry. Okay, they're definitely not line symmetry, right? Is there rotational symmetry, and if so, how? Could you twirl the shape on the left to become the shape spot where it's on the right? Use your imagination a bit about twirling. You can always use a piece of paper and trace it, and then try to spin it. Well, what do you guys think? If I say that this is a possible center point, how could you twirl it? Does that work? Yeah, if I twirl that, then this spot is at the same spot as that. Right? Does that make sense? This spot is this 180 twirl, right? And then I could also go back to the far D corner, but that would just overlap. And the A corner and the G corner are also the same kind of thing, but I'd be a really messy line. That shape, you can pick up the whole shape and twirl it over. Imagine what I'm doing with my hand there. Boom, 180 degrees. So there is related symmetry there, right? 180 degrees, so rotational symmetry. How do I have this explanation? No line symmetry, but 180 degrees. Okay. I think this is simple. I guess we'll put down 100. We say about the point. Now the spinning point is 0, 3. X then 1. Right? Now, Jackson, what are you looking down at? I don't know either. Look at the paper. Okay. How about symmetry with this one? There might be line, there might be rotational, or both. What is it, guys? Yeah, you think there's both? Definitely a line symmetry. Here, I'll talk about this first. What's the mirror line? I'll just, yeah, it's actual x-axis. I'm going to just darken that in. That's the mirror line. Then in green, I'll talk about rotational symmetry. What would you spin that about? What point would you spin that on? To get that other one. Somewhere right in between there, right? If I use that, that's like a two-blade fan, right? The top shape would spin into the bottom shape. And that coordinate-wise is 1, 2.5. So, and then there's rotational symmetry. About the point -2.5 with a height of 0 for 1. Both types. Lastly, okay, this isn't one shape. This is two shapes, but they're just on top of each other. So let's consider the ABCD the first shape. So it's definitely not a mirror image. It's not line symmetry. How do you spin this one, guys? Yeah, that's the dead center. You spin it 90 degrees. So rotational symmetry. That is the point, -5 for the x, 4 for the y. Okay, I want you to state ordered pairs with x, comma, y. And there's 3 textbook questions you should be able to do right now in the remaining time. We've got about half an hour, not quite, but close to it. And then we're wrapped up taking information. We'll talk about stuff on Wednesday as far as testing.